Welcome to the Explainer. Today, we are going to talk about something that's absolutely fundamental if you're working with databases, JDBC Transactions. We're going to break down how you can handle a bunch of database queries as one single safe operation, so you never have to worry about data just disappearing again. So, let's start with a picture. Imagine you're moving some money from your savings account over to your checking account. The system takes the money out of your savings, but then, bam, the power goes out before it can deposit it into your checking. So, what happens? Is that money just floating in the ether? Is it gone? This is the exact kind of nightmare scenario that transactions were invented to prevent. You see, what feels like one single action to us, a transfer, is actually two totally separate steps for the database. First, you have to debit money from account A, then second, you have to credit that money to account B. For this whole thing to work, both of those steps have to succeed. If one of them fails, the other can't be allowed to exist. They have to succeed together or they have to fail together. And this whole concept, this idea of treating a bunch of different steps as one indivisible unit, well, it has a name. It's called a transaction. It's the tool that makes sure our two banking steps are seen as just one single logical event.
And this really gets to the core of it. If you remember one thing, let it be this phrase: all or nothing execution. It means either every single step in your sequence works perfectly, or the database completely resets to how it was before you even started. There's no middle ground, no weird partial states, and definitely no lost money.
Okay, so that all sounds great in theory, right? But how do we actually make this happen in our Java code? Well, that's where JDBC, the Java Database Connectivity API, comes in. It gives us the exact tools we need.
Now, here's something you have to know. By default, JDBC connections are in what's called auto-commit mode. And what that means is that every single SQL statement you run is immediately treated as a finished and final transaction. For one-off updates, that's totally fine. But for our bank transfer with its two separate steps, that's a recipe for disaster. We need to take the wheel ourselves. We need manual control.
So how do we grab that control? It's surprisingly simple. It's this one line of code right here. By setting auto-commit to false, we're basically telling the database, hey, hold on a second. Don't make anything permanent just yet. I'm running a few things, and I'll let you know when the whole operation is actually done.
All right, so once you flip that switch to manual mode, every query you run is now in a sort of temporary state. It's in limbo. Nothing is final until you give the final word. And from this point, there are really only two ways this can end.
The happy path. The debit from account A works, the credit to account B works, everything is perfect. To seal the deal, you make a call to connection.setAutoCommit. This is you telling the database, okay, we're golden, lock it all in, make all those temporary changes permanent. And just like that, the transaction is successfully completed.
But what happens if something goes wrong? What if that credit to account B fails for some reason? Well, this is where we pull the emergency brake. You call connection.Rollback. This command is like a giant undo button. It tells the database, scrap everything we've done since I turned auto-commit off. It's as if that first debit from account A never even happened.
So when you put it all together, the whole pattern looks like this. You start by taking control, setting auto-commit to false. Then inside a try block, you run all your database commands, the debit, the credit, whatever they are. If you get to the end without any errors, great, you commit. But if any kind of exception happens along the way, your catch block is there to save the day, and it immediately calls rollback, making sure your database stays clean and correct.
We've just walked through setting flags and wrapping things in try-catch blocks. And it might seem like a little bit of extra ceremony. So what's the big payoff? Why is it so incredibly important to master this pattern?
It all comes down to this one powerful idea: data consistency. That's the promise. Using transactions correctly means you are guaranteeing the integrity of your data. It stops your database from ever ending up in some weird, illogical, half-finished state. It means money doesn't just vanish into thin air, and that your records always make sense.
Now, we've used a bank transfer as our example today, but this all-or-nothing principle is absolutely critical in so many other places. I mean, think about booking a flight and a hotel room at the same time, or processing an online order that has to update your inventory and create a shipping request. So I'll leave you with a question to chew on. Where in the systems you work with is this absolute guarantee of consistency not just a nice to have, but completely essential?